Welcome to another lesson. So today we continue on with the projectile motion topic. So if you haven't already done so, please visit the last two videos I did on projectile motions. The first one being almost the introductory lesson that shows all the formulas. The second one introducing the formulas in vector form, which is part of the new syllabus. Today we're going to do the harder questions in this topic. So questions that are normally, towards the end, if not the last topic of a 3-unit paper. So I've got some HSC questions for you today. So some of them are hard, not because of the numbers per se. It's just because there's a lot of proving, right? So you got to prove things in context of the projectile motion. So without further ado, let me just rehash some of the key formulae that we have in this topic. So if I just start here, once again, let me just zoom in a bit. So if you haven't already done so, please subscribe to the channel and like the video. It just helps with people trying to find these videos when they do the searching. So projectile motion. So we have a scenario where we project no air resistance, an object into the air, right? So to be clear, that has initial velocity of m meters per second at an angle of theta. Yeah. With that, a number of key formulae, right? So I'm not going to derive these here that we did before, equations of motion. Obviously, we have the horizontal ones that are relatively easy to prove. And just remember, if you were to prove these from scratch, you integrate each step. You start with acceleration, integrate downwards, right? So ignoring air resistance, pretty easy. You get these three. If you're keen for the air resistant ones as part of extension 2 4-unit, see the videos on that that I did way early in the year. So with vertical, so again minus gt plus u sine theta, and then I always do this. I do this with my classes, where if you have the vertical displacement, we always add. I always do it in brain for some reason. Plus h, which represents if you have an initial height or initial depression, that h represents that initial distance. So once you get that, now I say to my class, the most common things that you would normally derive is total time of flight, right? Where you can set initial, you set vertical velocity to be 0, and then you solve for it, and you get I lied there. You basically, I'm thinking about max height. You set the vertical distance to be 0, and you solve for that, and you get 2u sine theta on g. Right? You can memorize this, or you can prove it from scratch now, and then you get horizontal range. And I was saying to my classes, each one of these formulae are subtly different, right? So be very careful. So you can see the 2, the u and the g and the theta, all there, but in different arrangements. So the h equals to u squared sine squared on 2g, right? So we did that all in the last video. If you're curious how to prove it, sorry, the last 2 videos, see those. And of course, last but not least, you have the Cartesian equation, which basically removes the parameter here, removes parametric form into Cartesian. So you get 2x squared on, sorry, not 2, it's minus gx squared on 2u squared. Now you can have cos squared on the bottom. 1 plus tan squared is usually the format that they wanted at, plus tan theta x, and then just like before, if there is initial height, plus that. Guys, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 key formulae, right? Now we are going to use all these, and at times can I ask a favor, right? If the questions that I'm going to show you now from the HC asks us to prove it, we're not. We just take it and assume that you know how to prove these, right? If not, then look at the previous videos. But let's get move on. So the first one isn't too bad, right? But a lot of people can't do it because of the context. So let's have a look. So 3 questions today, all HSC, just to show you how, I guess, give you a glimpse of the difficult questions that are out there for this topic. So this topic, this question here from the HSC 2013, you basically essentially have 2 projectiles, one at A, one at B. One at A is projected at U velocity at alpha, while the one at B is projected at W at beta elevation, right? And it's such that there is a meeting of the 2 objects somewhere in the air, right? So nice little example, and they are d meters apart initially. So that's basically the context. If you want to read through the text, feel free to. The equation of motion fired from the origin, so this is at A, is given by, oh no, not at A. This is just generically, it's given by these formulas. So they basically gave you the equations of motion, right, from A and B. Yeah. So all you got to do is sub U alpha W beta into that formula for replacing V and theta, and you should get it. Right? So first question, let's go through this. How long does a projectile at A? Max height. There it is, right? So we can use it, right? You use the formula. In this case, I will, right? So theoretically, you can use it, or you can just prove from scratch. Show this, show that, right? Perfect. Now, I always say to my class, whenever you're trying to prove things like this, always ask yourself, A, what's given? And B, what's not given, right? Or what's not, what variable isn't in the thing you have to prove? And that should give you a glimpse of what you should do to prove these. So let's have a look. So part 1. Now we know max height, right? That had the formula u squared sine squared on 2g, right? So in this, if they're asking me to find at A, let's see, what do I know at A? I think, so bear with me. They're not asking me to doing how long does it? Oh, how long does it take to reach? Okay, that's even easier. So let me take a step back, delete this. I don't need that. All I need to do is basically what max height occurs when vertical velocity is 0. And I know vertical velocity is gt plus u sine theta, right? Now, in this case, the u is, u is u, but the theta is alpha equals 0, or sorry, minus, right, because of gravity. Right, if I made t the subject, which is what they're asking me for, right? So very important word there is how long, right? So I'm finding t, so t equals a question mark. And then it looks like all I have to do is to go, therefore, if I make t the subject, u sine alpha on g. Yeah, that's all I need to do now. It's no coincidence, right? That is exactly half of the total time of flight, because the maximum height without air resistance, right? If you think about it horizontally, maximum height's right in the middle, right? Because it's symmetrical. So that's the answer. Pretty straightforward. Now, it's 2 marks because I suspect you need to prove it from scratch at times. But in this case, I mean, I'm looking at the answers and it looks like that. So let's move on. Show this. Now, it feels like, what do you know, right? And this is the key point here. What do you know at the point of collision? Because that's basically the question, right? Yeah, if you sort of strip out all the other things compared to all the other questions, this is the thing that's unique about this question. They hit each other somewhere in the air. So what do you know happens at, now, let me see. And the key point here is that they collide at max height, right? They collide at max height. So what I know is there is a time when they basically collide, right? Max height. So in this case here, at this point here, the height is equal, right? So for both projectiles, so let's say H at A and H at B, they're equal. Yeah, by capital H, I mean max height, right? So that's the fact that I'm going to use to basically, hopefully, prove this guy. So I know, right, the formula for max height, which I wrote up before and I rubbed it out, was u squared sine squared on 2g. I know that. Yeah. Now let's see. Oh, actually, what do I know? Did I meet? So I know that's equal, but is there something about the time? The problem's when they reach max height. Okay. So point. Is there something about time? Another projectile is fine. Okay. So the time of collision is also equal, right? When they both reach their max height. So I'm going to basically say the time that it takes, right, let's see, reaches max height, t when they reach max height, time is equal, perfect. So I'm going to use part 1 to try to prove part 2, right? In other words, the time that it takes to reach max height for part A is equal to the time that it takes to reach for question A, particle A, the time that it takes to reach max height is going to be equal to the time that particle B is going to take, right? So I already did part for particle A, all right? So similarly, in fact, I don't even need the max height for this one. Don't even need it. So at A, I know that the time it took for max height is U sine alpha on G. Yeah. At B, I mean, the formulas are symmetrically equal, right? So it'll be, instead of U, it'll be W sine beta on G. Right, I know the time it took to reach max height, right, is equal. So therefore, if I set both of these to be equal, I'm hoping that's why it's only worth 1 mark, right? The U's cancel. Oh yeah, that's it. Yeah, that's it. Easy. So the G's cancel out there. And I have what I want, right? So not a hard question there per se, but just contextually, right, can be confusing. Yeah, and I'm hoping then that that is something I would use in the next part. Let's see. Show that now. I haven't used D yet, right? D is not used, so that's a distance between the two. So if that's a distance, horizontal distance between the two, it sort of feels like that. Show that D equals that. It feels like that if I took the horizontal distance that occurred for A, so let's say that is the distance at A, and I added that to the distance of B, right? This guy plus this guy should equal to D, right? The whole distance. So that's what I'm working with here. So now all I'm thinking is if it took this time here to travel to the max height, if I sum that time into horizontal distance, I'll get dA. If I sub the equivalent time that it took B into its horizontal distance, I'll find dB, and then adding them up, hopefully then the algebra sort of cleans up. Let me shift this up a bit. So guys, hopefully that's not too bad so far. Oops. Because then part 3 isn't supposed to be hard, but in this question, it's more about the context, right? So part 3, what I'm saying is right now, I know generically this formula for horizontal distance is what I'm going to use, right? X equals a V T cos theta, where at A, right? If I travel this time to max, I'm going to sub, yeah? So the distance of traveled by A is equal to U T, oh, not T, I'm going to sub in the time it took for max height, which is U sine alpha on G, yeah, and then cos alpha. Yeah, so it sort of looks like, what's that, U squared sine cos on G, all right? That's dA. Yeah, I'm going to leave that there for now. Let's see where it takes me, right? Let's see where it takes me. And similarly, at B, I should get exactly the same thing, right, going backwards. But let's talk distance for now, right? Displacement, and then I'll add it. So it'll be W sine beta on G cos beta. In this case, it'll be W squared sine beta cos beta. on G. So far, nothing too fancy there with what I've done. All I've done is say, well, if it takes that t here, so this t here and this t here to travel to their respective max heights, if I sub that time into the horizontal distance, I should get how far they travel horizontally. Add those two horizontal distances together and you should get d here. So add those two expressions there. I don't have enough horizontal space, so you know what, can I don't think there's a lot of algebra or something. Can I ask a favor? I'm just going to move this down here. And then, this is just so I can fit it all on the same page, right? Just makes it a bit cleaner. Okay, cool. Beautiful. So, and that since dA plus dB equals to d, right? Yeah, sub these two guys in. Let's see where that takes me. Therefore, d equals to u squared sine cos on also sine alpha on G plus w squared sine beta cos beta on G. Now, it's at this point that I sort of take a glimpse of what is over here, right? They got UWG, so they have all that, and they have sort of some indifference, right? So it feels like maybe what I'll do is if I, let's see, if I forced a W, if I forced a U out, oh no, I've done that wrong, haven't I? I've done that wrong, let's see. I've done that wrong. No, I haven't done it wrong. U cos W sine. Okay. I haven't done that wrong. Oh, it's right. Sorry, let me have a think. Right now, that's not giving me the right thing. So U sine. Yeah, I haven't used this guy over here, right? I haven't used part 2 to do this because I'm looking at this going, how do I get the compound angle for sine? Because normally the compound angle of sine has like sine alpha and cos beta, right? I need to use this, guys. So what I'm going to do, I'm going to see how it's u sine equals to w sine b. I'm going to try to borrow. I'm going to try, let's do this, right? Let's split this up. Let's put a u sine here, right? Let's put our u sine. So I'm going to go u sine. And what's left over? Let's see, u cos alpha on G, beautiful. Yeah, so this u sine, I'm going to replace with this. And similarly, if I strip out the w sine on this side, let's see what we get. W sine, beautiful. W cos on G, haha. And then I am going to replace this guy and this guy with the respective items upstairs. So it sort of gives me u sine is w cos. Oops. That's how you get the compound angle formula, right? That's cos alpha on G plus now w sine beta is equal to u sine alpha. There you go, cos beta on G. And you can see if I factorize UWG, it's cos. It's sorry, cos. I've subbed in the wrong one there. My bad there. So let me just get rid of that. It should be sine. Sine. Yeah, and then you get the sine compound. So let me. I need one more line. Ooh, I think I can shift this guy up. Squeezing one more line. Beautiful. Yep. So then factorize out what they want. Yep. Equals to sine alpha cos beta plus sine beta cos alpha, which is UWG, sine compound alpha plus beta. How's that? So, a couple of hitches. So I guess the key thing to remember there is always use the parts prior, right? So for a second there, I was like, how do I get this expression to look like the compound. Well, because there's alpha and alpha here. I was thinking double angles, but then I thought, well, you can't be double angles, right? Use the part above to basically sub it in so you get the alpha times beta action, right? Cool. HSC 2013, 5 marks. Now, the next 2 questions from the HSC as well, but a little bit older, are going to be much more intense in this, right? There's a good bit of numbers involved, so bear with me when I do it. So, hope that's okay. Next question. I love this question, right? So it's actually quite long. I've split it over 2 pages, right? So HSC 2007, where the context is actually great. So you got a paintball flying from the origin at angle of theta, right? And it hits a wall, right? Fired at a wall, is it? A barrier, 10 meters away, fired at initial velocity of 14 meters per second. So let me just circle what I have, right? So 14, that's you. Yep, 10 meters away. Yep, got that. 10 meters. Equations of motion are given. Great. Theta. Perfect. Show that trajectory is at. Now, what's M there? M is 10. Okay, so they've just replaced. You know how normally you have like 10 in your formula? They just replaced 10 with M. Show that the paintball hits the barrier there because it will. Remember, the Cartesian equation is an amazing equation because it's a double quadratic in terms of x and in terms of tan theta. So in this case, they basically want you to solve for tan theta in terms of for the equation, and it looks like that when that's 10 and it is h meters, is it? Yep, h meters above. So basically, they want you to sub in x equals 10, y equals a h into this Cartesian, and then solve it with the quadratic formula, right? And then determine the values for h. Determine the max value. Perfect. So that's part one. That's part 2. Let's just read it. Right? There's a large hole in the barrier. Okay. So basically, they're saying somewhere here there's a large hole. Right. The bottom of the hole is 3.9 meters above the ground. The top of the hole is 5.9. Paintball passes through. The paintball passes through the hole if m is in one of the intervals. In one of 2 intervals. Well, that's in find the other. Okay, cool. So it looks like we're going to have to solve something, solve the quadratic and sort of find the range. Right? Show that if paintball passes the hole, the range. Wow. Yeah. So once it basically, if it passes through the hole, show that the total range is that. Yeah. Now, I sort of read through that because I've seen this question before. The context is difficult, right? So a lot of people read through this a number of times to sort of really gather the information and the question and what he's trying to ask. But let me sort of cut through that. Let's just do the mathematics, right? So part 1, that's just the Cartesian equation based on this parametric. So I have x equal to 14t cos theta. That's given to me, and I got y equals to 14t sine minus 4.9 t squared. So if I make t the subject on this one, right, and what's that? X on 14 cos, and then sub this into the values of t there and there, right? These 2 guys there. I get therefore y equals to 14 x on 14 cos theta sine minus 4.9 x on 14 cos theta squared. Now I know the 14s cancel out here, so you get x10, right? So that is the mx, right? Because m is 10. This guy here is a bit more complicated. Yeah. So I'm hoping now 4.9 x squared on 14 squared cos squared. I'm hoping that 4.9 on 14 squared is 1 on 40. So let's check, right? 49 squared. 14 squared. Oops, 40 squared. Yep, 1 on 40. Perfect. So I know this guy's going to be x 10 minus x squared. That's x squared on 40, right? So, and then I'll turn it into x squared on 40 times 1 plus 10 squared. So I know, generally speaking, that's my Cartesian, but in this case, they basically replaced this guy and this guy with m. So therefore, y equals to mx minus 1 plus m squared on 40 times x squared. Perfect. Exactly what they want me to do. So that was 2 marks, Cartesian, nothing too fancy about that. And then, so let me shift that up. Yep. Now they want me to solve this quadratic, right? When they give me some information. So in this one here, show that the paintball hits a barrier, right, at height h. So I'm subbing in x equals 10. So let me just write this down, right? So for part 2, in this case, x equals to 10, y equals to h. Feels like I'm subbing everything here and then making m the subject. So it's a quadratic for m. So let me just make sure I'm not doing anything silly, because sometimes I freestyle and yep, that's absolutely fine. So when I sub that in, so I've got h equals to 10m minus, so that's 100, so 1 plus m squared on times 100 on 40, right? So that's 10 on 4. You know what? I'm trying to, well, they want decimals, so maybe turn that into 0.4 later. Is that right? Yep. Okay. So let's expand everything. You show that 10 on 4. So okay, cool. H equals to 10m minus what's 10 on 4? Is that 5 on 2? So 2.5 minus 2.5. I'm doing decimals. I normally do fractions, but they have decimals in the thing that I want. So it's just decimals minus 2.5 m squared. Now, if this is a quadratic, I'm going to divide everything by 2.5. So sort of that's why it's 0.4, because the reciprocal of 2.5 is 0.4. So times everything by divide everything by 2.5, so you get 0.4 h. 10 divided by actually, you know what? That's fine. What's 10 divided by 2.5? 4? Yeah, 4. So 4m minus 1 minus m squared. So I've got m squared minus 4m. And then, so I'm moving everything over plus. Plus. Let me just make sure the quadratic is right. I don't want to be. Yep, that looks perfect actually. Plus. Bracket here. 1 plus 0.4. Oops, 0.4h. Okay, that's my quadratic. So therefore, my quadratic solved might be minus b, so minus -4 plus minus root b squared minus 4ac all over 2a. Now I'm hoping this cleans up nicely, so let's see. 4 plus minus square root all over 2. And what do I have here? So I've got 16 minus 4 minus 4 after that. You know what? Yeah, no, I'll expand it, but then I have to factorize it again anyway, because I know that's 12. So if you sort of simplify that, it'll be 4 plus minus. So 12 is like 2. That's 3. Factorize 4 from that, 0.4 h on 2. The 2's cancel out, guys. And you get exactly what you want to say. Let's see, 2, 2, 2. And you get 2 and 1 there. So my final answer, therefore, m equals to 2 plus minus root 3 minus 0.4h. So nothing too hard about that, hopefully. It's just a little bit of algebra. And just make sure you get your quadratic right. That's your answer. So we're going well so far, 4 marks in this projectile where you're firing out a barrier in this case. Now let's do the harder part. So in the next question, so you know what, I will copy this diagram just so we can have a look at the context, right? So I'll uncrop that. Perfect. Okay. So we've done this one, done this one. Now there is a large hole in the barrier. The bottom of the hole is, so picture, this is the barrier that it goes through, right? So the height, the bottom of the hole is 3.9 meters. So from here to here, 3.9 meters. Top of the hole, 5.9 meters. Yeah, and the whole wall itself is 8 meters. Right? So 5.9 meters. The paintball passes through the hole. It passes through the hole. Yep. If m is in one of two intervals, one interval is that, the other interval. So basically it's saying, right, if you can imagine, right, to pass through this, and let me see if this is right, right, to actually hit this bottom barrier, I can fire my projectile one of 2 ways. It can either go like that on the way up, or on the way down, right? Oops, totally missed it. So let me scroll up with this so I can actually draw better. Yeah, so I can fire it on the way up, in other words, an acute angle, or fire it on the way down, which is obtuse, right? Similarly, for the top range, right? Yeah, so this is, both of these blue projectiles would have, would be one range, right? That's what they're saying is one interval, right? The other one is, if I project, sorry, for the top of the barrier, I can project on the way up, once again, on the way down, right? So this is how I'm going to play it. If I solve the blue, it should give me one interval for the angles, right? Because remember, m is just tan theta, right? So it's basically saying there's a range of angles that I can hit the blue, right? That's what m is, right? That's one of the intervals. There's a range of angles that I'm going to hit the red, right? The top of the barrier. If I sort of strive within that boundary, I will go through the wall, right? So in this question, right, for part 3, what they're really saying is when. Now let's deal with the bottom one first, right? Or the top one, it doesn't matter which order. Let's do the top one, right? Let's do the top one for the red, right? When the height is 5.9 meters, right? We're going to sub this 5.9 into this quadratic equation that we solved in part 2. Yeah, so if you punch both of these in your calculator, let's see. I think you get 2.8 or 1.2. Now see that 2.8? That's the bottom range, right, of this guy here, and I'll explain what that means in a sec. But let's solve the other one as well. When h equals to 3.9 meters, so the bottom range of the barrier, right? M equals to 2 plus minus square root 3 minus 0.4 of 3.9, and you get m equals to 0.8, comma 3.2. Now, what this means is that at the top one, actually, where's my highlighter? I don't have, so I'll highlight the blue, right? So for the top one, the 2.8 and the 3.2 is saying, I can fire top range so the top red and the top blue, right? Maybe that's the way to see it. If you look at the top red, the higher red, and the higher blue, that's these two, right? So if I fired top red, top blue, I can make it through the barrier. Alternatively, I can fire at bottom of both, so bottom red, bottom blue, and that gets me my other interval, right? So these two are paired up, so I can say therefore, right, to make it through the barrier, I can fire it with the two top angles, so it'll be 2.8 or 3.2, right? That's already given. The other interval there, therefore, is between 0.8 and 1.2, right? So they basically paired it up, the 2.8 and the 3.2, because remember, this is tan theta, right? The bigger the number, the bigger the angle for tan. Both of those represent the upper end, the highest angles that you can fire to make it into through the barrier. But if you fire, so in other words, if I sort of highlight the range that I'm talking about, so if you fire the two top ones, you're firing within this range, and you'll make it through the barrier, right? Alternatively, if you fire between the top bottom red and the bottom blue, you will also make it through the barrier. So you either take the green range or the yellow range. The green range represents this one. They already gave us that. That's not what they want. The yellow range represents the new one, and that's exactly what they want. Does that make sense? So we're firing within the yellow range. Now, that's part 3. That's hard, right? The hardest thing is not necessarily the mass, it's the context, right? So show that if the paintball passes through the hole, the range is up. Okay. Hence find the width of the two intervals in which the paintball can land on the ground. So they're basically saying, and I'm expecting what they're saying. Let me just check. If I subbed in all the numbers, right? If I sub in all the numbers, I wonder if it gets me the same thing. So basically they're saying, if I took the green path and I subbed in both of these into the X, right? Into the X distance, right? The horizontal distance. The red might give me a range there, and the blue might give me there, right? And that is my gap, right? That's what they want me to find here, right? That's what they want me to find. It goes, hence find the widths of the two intervals in which the paintball can land on the ground, right? That's what they're saying. So first I've got to show the range, and then secondly I've got to find the widths once, so basically subbing in the values of them, yeah, to find the range for the green path and the range of the yellow path. So for part 4, right, I'm going to find the range formula. So I know the range formula. Range occurs when y equals 0. Yep. So once again, using my Cartesian up here, yeah, 0 equals to mx minus 1 plus m squared, 40 x squared. I'm trying to solve for x, so maybe factorize x out. X 0. I mean, x is 0. I don't care about this one. This is, so this guy here, don't really care about. It's this guy here that I care about. So x equals 2. Or maybe 1 plus m squared on 40. Let's do it in 2 steps. Equals m. Chuck the m over. Oops, I'm too low. Therefore, times the 40 up, divide the 1 plus m squared down, and I got it, right? 40m plus x squared. Beautiful. Oh, 1 plus m squared. Very nice. Yeah. So with that in mind, I now need to, sorry, I'm just going to shift all the working up a bit. Maybe to the left. Now, with that in mind, I'm now going to try to find, if I sub in values of m with the intervals, I should be able to find the horizontal distance gap, right? So you take the bigger one minus the small one. So for example, right, if I subbed in the first gap, right, the green gap, right, this one up here. So when x equals to 2.8, Yeah, maybe I'll call this R. Yeah, total range. Sorry, not X, when M, silly. When M equals to 2.8, yeah? You sort of get like at 40 times 2.8 over 1 plus 2.8 squared. Yeah, now if I punch that quickly in my calculator, 40 times 2.8 divided by 1 plus 2.8 squared, get 12.7-ish. Yeah, so 12.7 meters. Similarly, when M equals to the upper range, 3.2, right? Now, it doesn't higher the angle doesn't necessarily mean the further distance, right? Because a high angle might mean it falls shorter, right? And the lower the angle might mean it falls further away. So I'm expecting this to be lower. So let's say 40 times 3.2, 1 plus 3.2 squared. Now, if you do punch it in, I think it's 11.4. So it does fall shorter, right? So in this case, right, the gap, yeah. So does it say something like, okay, cool. Let's find the. So in this case, let's see. Yep, the width of the width equals 2. That minus that was at 1.3. 1.3 meters. Perfect. Nice. That's half the answer. So I'm just reading there's an exclusion. So, okay, cool. Cool. Okay, for the next one, it's actually interesting, right? It's actually quite interesting. So that works well, right? That's the green pair. For the next one, if you think about this range over here, right? Just so I can explore this. You know, I won't start a new page. I'm just going to borrow this space over here. And for the next one, it feels like, let me do the same thing. I'll show you why it's a bit different, right? Why there's a little bit of a complication. It's because of the technicalities of tan theta, right? So when m equals 0.8, right, I got r equals to, once again, sub it into the formula, 0.8 over 1 plus 0.8 squared. If you punch that in, I think you get 19.5. Sorry, I love, so just moving these slides around. Yep, so I can actually fit everything in nicely. So that's 19.5. Similarly, when m equals to 1.2, my max range is 40. 1.2 plus 1.2 squared. Right, if you punch that in your calculator, you get 19.7. Now, I think here is the interesting part of the question. It doesn't really say the word max, but it goes, find the widths of the two intervals in which the paintball can land at ground level, right? On the other side. Because if you think about it, right? If I'm firing between 0.8 and 1.2, yeah? What angle is that, right? Remember, m is equal to tan theta. And I know whenever you're firing a projectile, the maximum horizontal distance that you can always attain is when theta is 45. Yeah. So when theta is 45 degrees, you get max range. Now, why is that important? Because tan theta is 45. Sorry, tan 45 is when m equals to 1, right? So this is equivalent to when m equals to 1. M equals to 1 falls within this range. So just because at the if I fire on the bottom blue, right, it gets me to 19.5. If I fire at the bottom red, it gets me to 90.7. Actually, there is an optimal max distance if I fire it at 45 degrees, right in the middle somewhere, right? And that will give me to my maximum range. Yeah, that's actually, so I take that width, so that distance minus the 19.5, that will give me the maximum distance that it can land on that ground. So when m equals to 1, right, 45 degrees, I'm going to explore the scenario, right? When 40 times 1, and I'm expecting this to be the the highest range in all of these, right? Because that's the maximum range. So 1 plus 1 squared, what's that? I can do that with that. That's 45 by 2. That's 20 meters, right? you can see 20 meters is the maximum distance. So if I fire within that interval, right, the maximum gap that I can get, the shortest it can go to is 19.5. The longest it can go to is 20 meters, right? So therefore, the width, right, on the ground, right, that can be possible. The word can there is important. Right? Can be like is 20 minus 19.5, which is 0.5 meters. Yeah, so the width of the top one is 1.3, but the width on the bottom, it looks like it's 19.7 minus 0.5, but it's not. Because if I fire it at 45 degrees, I actually can reach 20 meters. So it's 20 meters being the maximum, and the shortest is 19.5. The width is 0.5 meters. Guys, I have another question. It's probably going to take a while. I'm going to leave this video here. I might do another video. I apologize. I said I was going to do 3 videos on this. I'm going to hack on another one just so I can cover the 1995 question, which is one of my faves on this topic. So it's a hard one again. Might take a while, but hopefully that gives you a flavor of how difficult this topic can be, right? Lots of words. The context is a bit different. Difficult, and that's what makes this topic one of the hardest in extension 1. So if you like that video, give me a like, subscribe to the channel, tell your friends. I'll see you guys next time. Thank you.